Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today we're going to be looking at the associativity of addition. This is a property that you can use to simplify expressions, expand expressions, and understand how an expression represents a real-world problem. Speaking of real-world problems, in the last video we looked at a rectilinear pond, and we found the total area of the pond. You'll see that I broke apart the 4 sub-areas into different place values. I found the sum of the decimal values, the tenths and the hundredths. I then found the sum of the ones place value, and then finally found the sum of the tens place value. The reason I can do this is the law of associativity. We can write each sub-area in expanded form. Expanded form of a number is rewriting a number as a sum of its place values. For instance, 4 and 32 hundredths is 4 and 3 tenths and 2 hundredths. Associativity of addition tells us that terms separated by addition in an expression can be regrouped and the sum will remain the same. So rather than adding these 4 values as they are, I can expand them and find the sum of the decimal values, the ones, and the tens. The sum of 32 hundredths, 8 tenths, 32 hundredths, and 4 tenths is 1 and 84 hundredths. The sum of 4, 8, and 4 is 16, and the sum of 20, 40, and 10 is 70. To me, these 3 numbers are easier to find the sum of than these 4. 70 plus 16 is 86, plus 1 and 84 hundredths is 87 and 84 hundredths. This is the same result as the sum of these 4 sub-areas. You'll see we get the same sum in 2 different ways because of associativity of addition. Associativity of addition can be applied to algebraic expressions. In order to rewrite this expression in simplest form, we need to first distribute the negative sign so that we have all terms separated by addition. Negative 2x squared and 3x are not like terms because this x is squared and this x is to the first power. Negative 1/2 x and 2 are not like terms because negative 1/2 x contains the variable x and 2 is a constant. Before we can apply the associativity property of addition, I need to make sure all the terms are separated by addition. So again, I'm going to distribute the negative and rewrite this as a sum of opposite. The quantity negative 2x squared plus 3x plus the opposite of negative 1/2 x plus the opposite of 2 plus 3 and 7/10. Now that everything is addition, I can simplify negative 1/2 x a little further. The opposite of a negative is positive. At this point, I can also drop all of my groups because the law of associativity tells us that the sum is going to remain the same no matter how the addends are grouped. So here I can drop all of the groups. Groups are defined by parentheses or brackets or fraction bars. Now the expression can be regrouped so that we handle like terms first. Let's regroup 3x and 1/2 x since they both contain x values. Let's regroup negative 2 and 3 and 7/10 because they are both constants. To find simplest form of an algebraic expression, we need to be sure that there are no more like terms. Negative 2x squared does not have another like term. The sum of 3x plus 1/2 x is 3 and 1/2 x. The sum of negative 2 and 3 and 7/10 is positive 1 and 7/10 because the value with the greater absolute value is positive, so it stays positive. Our simplified expression is negative 2x squared plus 3.5 x plus 1 and 7/10. In order to better understand associativity, let's look at something it's not. Associativity is not commutativity. Commutativity is when you rearrange values and put them in a different order. Associativity is regrouping values. So A plus the quantity of B plus C is the same as A plus B and then adding C. Associativity and commutativity both apply to addition and multiplication. Neither of them apply to subtraction or division. Let's look at these 2 examples of evaluating a numeric expression. In both cases, we want to rewrite the subtraction as adding the opposite. So minus 5 and 6/10 becomes plus the opposite of 5 and 6/10, which is negative 5 and 6/10. With associativity, first I choose to group the 2 negative values together because adding two negative values is more straightforward than adding a positive and a negative. In commutativity, I choose to rearrange so that the additive inverses are next to each other. I know that 3 1/10 will cancel with negative 3 1/10. I'm going to group the last two addends, 3 1/10, with negative 8 61/100, because I know it will bring me back to negative 5 6/10. The opposites cancel, just in a later step. With commutativity, I only have two values left to find the sum of, and in both cases, I end up with negative 6 1/10. Thanks for checking out this video about the associativity of addition. Remember, associativity means we can regroup addends, and the sum will remain the same. It is not commutativity, which means we can rearrange addends, and the sum will remain the same. Give this video a like. Hit that subscribe button and ring the bell so you're notified when I upload new videos that clear up muddy math concepts.